Okay, this is another video on four-phase power, superconductive grid using plasma as a motive force. The third time in the history of the United States and the world of an energy option. Michael Faraday, DC, Nikola Tesla, AC, David Puchta, LC current, plasma motive force. Today, we're going to have a deeper understanding of superconductivity over our grid. We're going to talk exclusively about linear magnetism and superconductivity, and then we're going to talk exclusively about the Bose-Einstein condensate is what you're seeing over the grid through the bow tie of superconductivity. Okay? Here's the temperature of our genset. We're at 60 hertz. Everything's settled down. 120 volts AC. 112 hertz AC. Perfect power. This is what I want to show you before the demonstration gets started. First, we're on the positive side. 512 volts. That's what you pump back to the grid. Here's the negative side. There's where you get the power from the grid. So you're effectively using all the power, completely upsetting the kVAR calculation that cost you your power bill and the distribution associated cost. Okay? Normally it's the other way around, by magnitude. Look at your bill and understand kVAR. We'll talk about that later. We are now boiling coffee, okay? Infrared. We are at 190 degrees boiling coffee. Take the infrared off. The glass is 192 degrees. The plastic is only 107 degrees, okay? Touchable, pretty expected. But watch this. You see the metal band? 600 degrees. Same as this stainless steel over here, right here at the bottom. But the aluminum here is only 400 or 500 degrees, effectively turning your standard cooktop into a 100% efficient radiant heat cooktop. You cannot use one of these pans on a regular cooktop. You will burn that pan. This is proof that now your ranges have now imposed the superconductive field and changed the magnetic ordering of the carbon to graphene in your cooktops effortlessly. You do not need to change your appliances. Now look, 187 degrees, making steam out of your tea. I want you to see something. Pay close attention to the waving effect and how close that paper is to the heating element, but it's not catching fire, even though the heating element is technically 500 plus degrees. 400 something catches paper on fire. Okay? It's safe energy. That radiant heat is coming up in a helical. That's why the tea bag tabs are waving. You can see the steam coming off the water, but we're only 170 degrees. That steam is extremely healthy for you. So now we're going to take our coffee and we're going to let it cool down, and we're going to taste the coffee. I pretty much guarantee you, you're not going to ever burn food again. These radiant cooktops, not with this element, but with the regular element, you can definitely burn food. It self-regulates on the atomic level. Okay? Now, we're going to move forward into the Bose-Einstein condensate, where the electrons go into a wave. This power right here is the superconductivity imposed over electromagnetism, and the energy goes into a wave at 201 milliamps and then up. This is the energy running on its own power. No power input from the grid. Okay. What you're looking at is a tool. This is called a Zohm tool, and it's perfectly matched with the atomic level, the chemistry, and fractal geometry in nature. Every one of these balls has all the Fibonacci angles, all of the angles that we know about in fractals, to allow you to properly build the crystalline structure in whatever you want, from the atomic level to metals and so forth and so on, including electricity. You have to remember something, that electricity, gas, and fluid all run in the same principles of engineering. You engineer them the same. So the Zohm tool that you can purchase through Magnetic Arts, I'll give the link on the website, we're a dealer, or your convenience online. It comes with all these different sizes, and that's all you need. I'll flip through the book, and you can see how nifty the angle is. And if it doesn't fit, it does not exist in nature. Everything that you can possibly imagine. The reason this tool is so important, because you cannot impose yourself on a CAD drawing to come up with a fractal geometry of this nature. This is the mind-boggling of fractal geometry. What is big is small. So this Zohm tool gives you all of the parameters of how to set it up. It's a very interesting tool to use. I'm asking you to take a moment and purchase. If you don't already know about these. Okay, that's enough of that. So what you're looking at, this is the copper crystalline structure. Properly put together with a carbon atom at the atomic level. The red indicates the protons. Okay? The blue indicates the electron bond. And the carbon 12 has 2 electrons in the center and 4 electrons around the outside at its ground state. The protons are set in their orbit. The neutrons are the magnetic charge in superconductivity, okay? And in magnetism, so we can be clear on that. So everything in the compression of carbon is completely bound. The electrons cannot move. They have no place to go. Now we take this and we've made the carbon now graphene, because now the metal has been set, okay, in the crystalline structure, and all we're doing is liberating the carbon and breaking the column bond now that the metal has been set, to give the graphene a place to gyrate. And you see the neutrons here and the protons. If you go to the primer fields of David LaPont, you have to assume to the atomic level of the proton. The name of my company is Proton Spin Technology for a reason, because I understand how to control the spin of the proton, effectively able to stop nuclear in its tracks. That was necessary to be said. As you can see, I've made the neutrons longer because they're grabbing the up and coming linear magnetism through the Cooper chain, the Cooper-Puchta chain, the superconductive tunneling that's gone through the copper or the steel lattice, to be able to flip the graphene at 26 trillion hertz before the electron even thinks of getting there. The graphene has flipped like this and said thank you, and the revolving door has pushed that electron through it and past it before it even got there, sort of like a turbocharger. Correctly defined in the most astute math, fractal geometry. I spent 8 years in decorative arts. My mentor and teacher is Joanne Day from the Day Studio Workshop in San Francisco. She gives all of the colors for Benjamin Moore. She taught Steve Jobs fractal geometry so that he could build the Apple computer. It took me 8.5 years to wrap my head around fractal geometry. Let me show you. This is what we see on the oscilloscope. Okay? You see that? And on the other videos, when we're cycling, you see the charges on the cross lines. The white balls are electrons, and the blue is the superconductivity. This is the bow tie of superconductivity. So we start by looking at it, and you can see naturally the curvature, but you see the top here? There's one tunnel, and there's the other tunnel of the superconductivity right through there. But it's more importantly looked at right through there, in any angle that you want the electron to go. This kind of math cannot be done with a CAD drawing until you do it here first, because nothing has changed. No pieces are forced together. It naturally fell into place. Okay? You can see the same similarities here, where the energy rolls in upon itself. You can see the same scenario here, where the energy rolls in upon itself. It's self-regulating. Here's what happens in superconductivity. This is the representation of the Meissner field. The blue would be the cold, bringing on the superconductivity, which allows the magnetic field to move the compasses in the Meissner effect, thinking that the magnetism is going around the metal and the metal is going past with no resistance because there's no magnetism. That is not true. This is now the truth. This is what's happening. If you notice, the blue is the cold. The yellow is the magnetism. It's been here the entire time. Now, once the superconductivity is imposed on the carbon, it simply takes this carbon that's bound, opens up the electrons to graphene, and then when you add more cold, Einstein proved that the electron and electromagnetism comes back into a Bose-Einstein condensate. But as you're going through the heat cycle and coming back up through room temperature, you ultimately end up with this superconductivity right here. Do you see how the scallops? Those scallops, you have to take that with your mind and do this. Those are inside of this. This is the inside, that is the outside. All the way down to the atomic level. This is this tunnel right here. A superconductive Puchta chain. Cooper-Puchta chain. And the tunneling effect of superconductivity over our wire. Now, I'm going to have a little break. The coffee is absolutely perfect temperature, and I promise you, I'm a coffee hater. I do not like coffee. That coffee is not burnt, even though we boiled the snot out of it. Now look, it's only been a couple of seconds or a minute, and all of the water is gone in the pan. You see that? Gone. So we're going to go ahead and leave the pan on the burner, and we'll check the temperature in a couple minutes and figure out what it is. Here's my coffee temperature. Perfect temperature for your coffee, 140 degrees. No burnt tongue. So, let's do this. Let's fry some ceramic fish and figure out what the temperature is. Okay, we'll start at 200 and the fish will start at 83. We'll check that in a couple minutes. Okay. The other fallacy of superconductivity. We can only check resistance in one direction. I'm going to move this over here. Here is what's going on. You see this? You see the charge of magnetism on the right and the left? It's higher specifically on the right. As we induce the DC electricity or AC for impedance on resistance, the charge can flip and make you think that there's no resistance. Okay, so we check it the other way. It flips at 26 trillion hertz. So you think you have resistance in both directions. Okay, you impose the field. What happens is that the red is the indication of the Bose-Einstein condensate amplifying the magnetism through the superconductive wave and pushing the Meissner effect. So the magnetic field is set around the experiment, but technically the electrons are going in both directions. I think it was very important that you understand a little bit more about superconductivity and our new superconductive grid. Thank you for your time. I will talk to you soon. I almost forgot. We need to check our fish. One more time. Perfect linear pole magnetism, 4-phase plasma power doing motive work. These videos are also baseline for future engineers. When you see this on your oscilloscope, everything is just fine. Let's check our fish. The pan, 269. The fish, only 128. Perfect radiant heat. It's a ceramic fish with some gold and some other things. Let's see if we can pin this metal. 162. 154, 137, and 130. Right there on one piece of ceramic, 3 different temperature gradients. I'm going to have some tea now. My work for the day is done. Thank you very much for watching. This is your understanding of superconductivity and our new 4-phase power superconductive grid, specifically answering Greta Thunberg. You're welcome.